So one of the great things about this lab is when Dr. Harp designed it, he did everything to scale. So in the scale of that light bulb, which represents our sun, he took that as the size of the sun, and then he scaled planets, made planetary cards, and these little specks represent the actual size of the planet as compared to the sun. Now we get to run out there with the meter tape, and we start putting in our planet cards as we approach the appropriate distance away from the sun, again to this scale that we've been describing. And by the time we're about 150 meters out, we've got that tiny little speck. And we look back at this light bulb and we're talking about how much energy is moving through our solar system to try to warm this planet as compared to how much actually arrives at our planet and drives our planetary system. It's a really, really neat lab that he's developed. It's really great.
I'm Teresa Adams. I'm an embedded tutor in the geology department. And right now the students are looking through these telescopes to see if they can determine sunspots. As we take the sunspots for our observations, and they change throughout the seasons.
So to the size of the sun. And part of the point is this is such a massive thing. This represents 99% of all matter and mass in our solar system. And so now you can kind of get the feeling that that's true, right? Because everything's done to scale. That same scale, and we can lay out how far apart they are using that size as well as these sizes. And that's where your table 3 came in. So you took your average planetary distance in terms of orbit, and you turned that into a meter measure. What's the first planet from the sun as we work our way outward?
Just line up with this. This one, right? Down towards the line. I don't know if the letter